For centuries, humanity has asked one question: are we alone? Today, scientists believe they may have found the strongest evidence yet that life could exist beyond Earth. A distant planet, a mysterious chemical signal, and a discovery that could change our understanding of the universe forever. But is this really evidence of aliens? Or are we seeing something else entirely? For as long as humanity has looked toward the stars, one question has refused to disappear. Are we alone? Ancient civilizations imagined gods living in the heavens. Philosophers debated whether other worlds might exist beyond our own. Today, that same question is no longer asked only by dreamers. It is being investigated by astronomers, planetary scientists, chemists, and some of the world's most powerful space telescopes. For centuries, we had no way of answering it. The nearest stars were simply too far away. Even the largest telescopes could only see tiny points of light. No planets, no atmospheres, no clues. Then everything changed. In the last 3 decades, astronomers have discovered that planets are not rare at all. They are everywhere. Thousands of worlds have now been confirmed beyond our solar system. Some are frozen. Some are scorching hot. Some are gas giants larger than Jupiter. Others are rocky worlds that may resemble Earth. Every new discovery has transformed our understanding of the universe. Instead of asking whether planets exist around other stars, scientists are now asking something far more profound. Could one of them already be home to life? The search for life entered a completely new era with the launch of the James Webb Space Telescope. Unlike traditional telescopes that mainly observe visible light, Webb is designed to study the universe in infrared. This allows it to peer through cosmic dust and, more importantly, analyze the atmospheres of distant planets. When a planet passes in front of its host star, a tiny fraction of the star's light travels through the planet's atmosphere before reaching the telescope. Different gases absorb different wavelengths of light. Like fingerprints, these absorption patterns reveal which molecules are present. It is an astonishing technique. Scientists can identify water vapor, carbon dioxide, methane, and dozens of other molecules from planets located hundreds of light years away. For the first time in history, humanity is no longer limited to discovering distant worlds. We can begin investigating what their atmospheres are made of. And among thousands of known exoplanets, one world quickly became the center of global attention. Its name is K2-18b. K2-18b lies approximately 124 light-years from Earth in the constellation Leo. It is much larger than our planet, with a diameter about 2.6 times greater than Earth's and a mass nearly 8.6 times higher. Although it is not considered another Earth, it occupies an intriguing region around its star known as the habitable zone. This is the distance where temperatures may allow liquid water to exist under the right conditions. Previous observations had already detected water vapor in its atmosphere. That alone made K2-18b one of the most fascinating planets ever discovered. Then came something unexpected. When scientists analyzed new observations from the James Webb Space Telescope, they reported possible evidence of molecules rarely seen together in planetary atmospheres. One molecule, in particular, immediately captured worldwide attention. A compound that, here on Earth, is primarily associated with life in our oceans. The discovery made headlines across the globe. Some called it the strongest evidence yet for life beyond Earth. Others urged caution, reminding everyone that extraordinary claims require extraordinary evidence. One thing, however, was undeniable. For the first time, scientists had found a signal they simply could not ignore. But what exactly was this mysterious molecule? And why did it excite astronomers around the world? That answer could change the search for life forever. For decades, the search for extraterrestrial life was driven by hope. Now, it was being driven by data. A distant planet had revealed a chemical signature unlike anything scientists had expected. The question was no longer whether the signal existed. The real mystery was, what created it? The excitement surrounding K2-18b was not caused by the planet itself. It was caused by a single chemical signature, a molecule called dimethyl sulfide, or simply DMS. Here on Earth, DMS is produced almost entirely by living organisms. Tiny marine phytoplankton release it into the oceans. From there, it enters the atmosphere, becoming part of Earth's natural sulfur cycle. For decades, astrobiologists have considered DMS a potential biosignature, a chemical that could indicate biological activity on another world. That is why the announcement immediately attracted global attention. Using observations from the James Webb Space Telescope, researchers identified spectral features that were consistent with the possible presence of DMS, along with another related molecule known as dimethyl disulfide, DMDS. If confirmed, this would represent one of the strongest biosignature candidates ever detected beyond our solar system. But there was one important problem. Scientists had not actually seen the molecules. They had detected patterns in light that could be explained by those molecules. In astronomy, that distinction changes everything, because sometimes the universe can imitate the fingerprints of life. No spacecraft has ever visited K2-18b. No probe has sampled its atmosphere. Everything scientists know about this distant world comes from light. When K2-18b passes in front of its star, a tiny fraction of the starlight filters through the planet's atmosphere before reaching James Webb. Every atmospheric gas absorbs specific wavelengths. The result is a unique spectral pattern, almost like a barcode. Astronomers compare these patterns with laboratory measurements collected here on Earth. If the patterns match closely enough, they can estimate which molecules are present. It is one of the most powerful techniques in modern astronomy, but it is also one of the most challenging. Signals from distant planets are incredibly faint. Tiny measurement errors, instrumental noise, or even unexpected atmospheric chemistry can produce misleading results. This is why researchers never announce the discovery of extraterrestrial life based on a single observation. Instead, they test, retest, and challenge every possible explanation. The goal is not to prove themselves right. The goal is to eliminate every alternative until only the most likely answer remains. The possibility of DMS on K2-18b generated headlines around the world. Some media outlets declared that scientists had discovered evidence of alien life. The researchers themselves said something very different. They described the result as promising, but preliminary. Further observations would be essential. Since then, astronomers have continued examining the data using improved atmospheric models and additional James Webb observations. Some studies suggest the signal could indeed represent DMS or DMDS. Others argue that different combinations of molecules, or atmospheric conditions we do not yet fully understand, might produce similar spectral features. This is how science moves forward, not through certainty, but through constant testing. Today, K2-18b remains one of the most exciting worlds ever discovered. Not because scientists have proven that life exists there, but because it is one of the few places where the question can now be investigated with real observational evidence. For the first time, humanity is not simply imagining life beyond Earth. We are collecting data capable of answering the question. And if these signals are eventually confirmed, they may represent one of the greatest scientific discoveries in human history. For generations, the search for extraterrestrial life belonged to philosophy. Today, it belongs to observation. A distant world has offered humanity a tantalizing clue. Not proof, not yet, but perhaps the strongest clue we have ever found. Now the final question remains. If these signals are real, what happens next? Extraordinary discoveries demand extraordinary verification. That is why no serious scientist has announced the discovery of extraterrestrial life. Not yet. The observations of K2-18b have opened an entirely new chapter in astronomy, but one observation alone is never enough. Every possible explanation must be tested. Could the signal have been created by unfamiliar atmospheric chemistry? Could another molecule produce a similar spectral fingerprint? Could instrumental noise have influenced the measurements? These are not obstacles. They are the foundation of science. Every great discovery in history has survived years of questioning before it became accepted. The same process is happening today. The James Webb Space Telescope continues to observe K2-18b, collecting more precise infrared spectra with every new transit. Meanwhile, astronomers are building increasingly sophisticated atmospheric models, using powerful supercomputers to simulate thousands of possible planetary environments. Each new observation narrows the list of explanations. Each new dataset brings humanity one step closer to an answer. The goal is not to prove that aliens exist. The goal is to discover the truth, whatever that truth may be. James Webb is only the beginning. Over the coming decades, an entirely new fleet of observatories will continue the search for life beyond Earth. The Nancy Grace Roman Space Telescope will help astronomers discover and characterize countless new planetary systems. The extremely large telescope, currently under construction in Chile, will use its enormous 39-meter mirror to study distant worlds with unprecedented sensitivity. Future missions, including concepts such as NASA's proposed Habitable Worlds Observatory, are being designed with one primary objective: to search for unmistakable signs of life on Earth-like planets. At the same time, robotic explorers closer to home continue investigating worlds that may also harbor life. NASA's Europa Clipper is on its way to Jupiter's icy moon Europa, where a vast global ocean is believed to exist beneath the frozen surface. Later, Dragonfly will explore Saturn's moon Titan, searching for the complex chemistry that may resemble the earliest stages of life. The search is no longer focused on a single planet. It spans our solar system, our galaxy, and beyond. Humanity has entered an age where the question is no longer impossible to investigate. Imagine waking up one morning to a headline unlike any in human history. After years of independent observations, multiple telescopes, and countless scientific reviews, astronomers have confirmed the first undeniable evidence of life beyond Earth. Not a mysterious radio signal, not an unidentified object, but a living world. Perhaps nothing more than microscopic organisms drifting through an alien ocean. Yet even the simplest form of life would transform our understanding of the universe forever. It would mean that biology is not unique to Earth, that life can emerge wherever the conditions are right. And if life can appear more than once, then the universe may be filled with living worlds waiting to be discovered. Whether K2-18b ultimately becomes that historic discovery remains unknown. The current evidence is intriguing but not conclusive. Science has not reached the final answer. It has reached the point where the answer can finally be tested. Perhaps that is the greatest breakthrough of all. For thousands of years, humanity looked at the night sky and wondered whether anyone else was out there. Today, for the very first time, we possess the technology to begin answering that question with evidence rather than imagination. And somewhere, 124 light-years from Earth, a distant world continues to orbit its small red star, quietly holding on to a secret that humanity has only just begun to uncover. The search for alien life has never been about proving what we hope is true. It has always been about following the evidence. Today, that evidence is stronger than at any other point in human history. Not because we have found aliens, but because we have finally learned how to recognize the faint chemical whispers that life might leave behind on worlds hundreds of light years away. K2-18b may or may not become the first confirmed living world beyond Earth. Only future observations will decide. But one thing is already certain. Humanity has entered a new era. For the first time, our greatest question is no longer beyond the reach of science. And somewhere in the vast darkness of the cosmos, the answer may already be waiting.